Let's do our first example, which is a piecewise defined function. So even though this is really a piecewise linear function because both are lines, we can kind of figure out what this is. So notice here we have a function that has two parts to it. So we have a line that's 3x plus 2 when x is greater than -1. Remember on this graph here, and this is just an example, this may not be the one that's actually correct, but let's take a look at this one here. So here is -1 located right there. Okay, so then anything greater than -1, which would be to the right, it's telling me that the line looks like 3x plus 2. When x is to the left of -1 or less than or equal to -1, then we have -1/2. But this is giving us some information here. So we're trying to figure out which is the right graph. So we're trying to figure out which one is the right graph. Let me pause this just for a moment. Okay, to get back where I was, sorry, I was interrupted. But notice here that we can see that it's when it's greater than -1, when it's to the right of -1, and we're always looking at the x value, right? So it says x is greater than -1. So here is x equal to -1. When it's greater, when it's going in this direction, right, like that little arrow that I drew down there at the bottom, when it's going in this direction, notice here that it says when it's greater than. But this closed circle means greater than or equal to. So therefore, this has to be an open circle here. And this one here has to be the closed circle. So this one would not work just because of this part right here. Let's take a look at the next one. So let's take a look at A. A says greater than, and this one says less than or equal to. So there's a possibility that that could be. We don't know yet. We're going to put a question mark there because we're still going to keep searching. Notice how both of them are equal to. Definitely is not. And it wouldn't be a function if both of them were equal to. And then this one here, both of them are not equal to. So notice in this case, we can actually figure out the answer just by looking at that. So notice in here, the answer has to be A because of that. Now notice what I do over here is I graphed it. So I graphed it on this screen, and you'll see I created a new function called g of x equals 3x plus 2, and I said when x is greater than -1. So notice it graphed this line right here. I did -1/2 x minus 3 when x is less than or equal to -1. So when it's less than, which is this way, so it would be this line right here. And what's the problem with Desmos and sometimes with all these different software packages, it does not put an open and a closed circle there. So I have to put it in. So notice what I did is I said, okay, I want to find out what this value is right here because this is a closed circle. So I did h of -1, which means that the computer will go in and plug in a -1 here, and it gives me a number, -2.5. Notice there it's at -2.5 because this is -3, so this is halfway in between. And so then I said, okay, draw a circle. So I just put in parentheses -1, which is my x, and -2.5, which is my y. That's how we deal with functions. Remember that x is always comes first, and remember that y is always f of x, right? So instead of putting y here, we put f of x. But that labels that point there. So now notice this graph looks exactly like the one that I have on the answer. So I just wanted you to see that on how to do it in Desmos, because actually you can graph it on Desmos to test your answer and to try to understand it better. I think a lot of times seeing it visually really does help out. And notice that when I turn on these different things here, right, it creates the functions that I did. You can actually turn off your functions. So instead of deleting these things, a lot of you guys like to delete things. I would just keep them and just keep going down. So that way, if you have to go back and reference any of the stuff that you had before, you are able to do that. Okay, so at least for now, I'm going to stop here for example 1, and we're going to continue on with the rest of the examples. I know I said I was going to stop, but actually I forgot to do a part. So stating the domain and range. So remember that this is the function right here. So the domain are all the x values going from -infinity to +infinity left to right. So notice this arrow keeps going to the left, and this arrow keeps going to the right, and there is no break. So because of this solid line and this open circle, sorry, not solid line, this closed circle versus this open circle, the function just keeps going. So it runs all the way from negative infinity to positive infinity, which means all real numbers. So all real numbers on the x, right? And then for the range, we go up and down. So taking a look at that, notice that this function goes no further down than this point right here, right? So right at that point, it goes no further down. It just goes up. So that means my y value, or my f of x value, I'll do y value and then I'll rewrite it, but my y value has to be greater than or equal to that number, which is negative 2.5, or f of x is greater than or equal to negative 2.5. Those two things mean the same thing. So let's look for that. So all real numbers on the domain, greater than or equal to negative 2.5 on the range. So domain, all real numbers, can't be that one, can't be that one, greater than or equal to 2.5, so it has to be this one right here, so that would be B. Okay, so that is now the end of that problem.